Hello, welcome to Math Review.
So what is a normal distribution? A normal distribution is a probability function that describes how the values of a variable are distributed.
So in statistics, there are two components, main components, which is inferential statistics and descriptive statistics. Now, the normal distribution is under descriptive statistics.
Hello again. A normal distribution follows a systematic process that describes the values of a given data set as a bell-shaped curve. The highest point of the curve, or the top of the bell, represents the most probable event in a series of data, while all other possible occurrences are equally distributed from the peak, which creates a downward sloping line. As you can see.
What we did as a group to prove that normal distribution could be applied or proven in real life, we played a little game of Monopoly. Well, to prove that there is normal distribution there is the application, or we used dice.
So in this value, the only combination of getting a 2 is only 1, which is 1 plus 1 in this dice. So in this data, we see that the highest number of combinations is a 7. So in our game of Monopoly, in 100 times of rolling the dice, we took note of the values that each of the players got. So this is our hypothesis. 7 being the most, and 2 and 12 being the least. So, let's prove this by playing a game of Monopoly.
A normal distribution is a kind of descriptive statistic that describes the most probable outcome of a given data set by determining the mean.
since we're determined the normal distribution of the two dice, we're going to find the z-score of the normal distribution. So, the z-score is simply the number of the standard deviation from the mean a data point is. So, to talk more about z-score, let's invite Laika to tell us more about this z-score.
To find out the value of the z-score of a normal distribution, we need to first find the mean and standard deviation of a given set of data. To find out the mean and standard deviation, let's look at the table of values from our game of Monopoly.
So in this table, we'll find the mean and the standard deviation in order to get our desired z-score. From our calculations, the mean of rolling 2 dice 100 times is 7.19, with a standard deviation of 2.58.
The formula of the z-score is seen as x subtracted to our mean, divided by the standard deviation. Now, let's apply computing for the z-score using our data from the Monopoly game.
So say for example, in a game of Monopoly, a 2 dice rolled 100 times has a mean value of 7.19, with a standard deviation of 2.58. What is Norman's z-score if his dice rolls with a value of 3? Since we have a mean of 7.19 and a standard deviation of 2.58 with our x as 3, we will substitute these values to our z-score formula. Our z-score will then look like this. 3 subtract to 7.19 divided by 2.58 is equal to negative 1.62.
In order to find the area under the normal bell curve of our desired value, we must first look at the z-score table. In finding the area under the bell curve using our z-score, we interpret the score using the z-score table. In finding the area under the bell curve, take your z-score and find the corresponding values in the left column using the first two values of your z-score. Then, find the last digit on the first top row of the table. Find the intersection from the left column and top row, and you can find the value of the area of your z-score under the normal distribution bell curve.
So looking at our z-score table, we will then find out the value of negative 1.62. Looking at the left column, look for the negative 1.6, which is our first two values, and then at the top row, 0.02. The intersecting value will be 0.0526. Therefore, Norman's z-score value of his dice roll of 3 is 0.0526 or 5.26% area under the normal distribution bell curve. So that's all for this episode's math review. I hope you learned something new about the normal distribution and the z-score. This is Max and you're watching Math Review.